So the contents of the atmosphere is roughly in the following percentages. We have about 78% nitrogen. We have about 21% oxygen. About 0.9% argon, which is an inert gas. And the rest of the, 0.1% are other gases. This can include carbon dioxide, nitrogen dioxide. It can include methane. It can include, a little bit of hydrogen and helium. Very, very little of those, et cetera, et cetera. And one can look at these percentages, and one can just kind of look them up and memorize them. But the point here is, we can ask the question: why these percentages? Why is it dominated by nitrogen? Why does oxygen have a significant percentage, and so on? And that's really the critical point. And it is important to understand in the atmosphere what function each gas plays, kind of what effect it has on the atmosphere, which things produce it, do they do anything chemically, etc. So the easiest one to start with is oxygen. Oxygen is highly reactive, reacts with rocks, produces rust, reacts with a lot of other things, and so if left by itself, it would pretty much disappear in the atmosphere, just combined with everything. So in order to have significant amounts of oxygen in an atmosphere, you need to have life. So oxygen is pretty much a telltale sign for life. And if we were ever able to measure the atmospheres on other planets, if we found that oxygen was on them, that would be a significant indicator of life. And so that's the kind of life processes produce oxygen and kind of maintain oxygen at a high percentage. Nitrogen pretty much comes from volcanoes, and mostly from the past. And so and nitrogen does not combine with a whole lot of other things. So it's not particularly chemically reactive. So it doesn't combine with the rocks or the water. And so it is able to kind of maintain itself after being produced by the volcano. So in the past, there were many volcanic eruptions that threw nitrogen into the atmosphere, amongst many other gases. Those other gases tended to either be light, like hydrogen and helium, and leave the atmosphere over time, or they were chemically reactive, in which case they reacted with other things and were taken out of the atmosphere. Nitrogen maintains its high percentage. So those are the kind of two processes that are going on. Now, the other gases, like for instance argon, doesn't react with anything, and so it is neither produced by the chemistry or taken out by the chemistry. These other gases, say for instance carbon dioxide, is also related to kind of living things, and even though it is a small part of the overall atmosphere, it can have a major effect as a greenhouse gas. So just because something has a small percentage does not immediately mean that it is unimportant or can't have a significant effect. So the greenhouse gas effect essentially lets those gases absorb certain amounts of radiation, and because of that, it tends to warm the atmosphere. So we get a kind of a warming effect from even a tiny amount of some of these gases, and so that would mean that changes in those, may affect that process, and is what is currently under investigation under climate change, global warming, those sorts of labels, and we'll talk about that. In all of this, I have omitted perhaps the most important greenhouse gas, and one of the more important gases in the atmosphere, and that is water vapor. So we have water vapor, and that is very critical for all of the weather. So it becomes important. Now, the reason why it's not often listed when they list off the constituents of the atmosphere is that it's not constant. So it's not even remotely constant. It changes, it fluctuates. The quantity of it changes from one place to another, from one time to another. It can range up to like 4% of the atmosphere, and all of the weather, the clouds are made up of condensed water vapor droplets. All of the weather is driven by water vapor and by the changes in water from its various states. So these are the constituents of the atmosphere, and then a lot of understanding how an atmosphere works is understanding what processes produce these gases, which processes take these gases out, what processes move these gases around, and how does that affect things like temperature and pressure and humidity and the rain and the weather systems and so on.